Hello dear students of physics, especially for 9th class, respected teachers. In this video, I am going to discuss about non-uniform motion. This is third part of linear motion for 9th class. Now, non-uniform motion is of two types. One is uniformly accelerated motion, other is non-uniformly accelerated motion. Now, uniformly accelerated motion means when velocity of the body changes by equal amounts in equal intervals of time, howsoever small these intervals may be, then motion is said to be uniformly accelerated. Means velocity changes at constant rate. It may increase, it may decrease. Second, non-uniformly accelerated motion. It is that motion in which velocity of the body changes by unequal amounts in equal intervals of time, howsoever small these intervals may be. Means velocity changes or varies, may increase or decrease at unequal rates. So in this video, I will discuss only uniformly accelerated motion for 9th class especially. So for that, we have to plot how position of the body varies with time, how velocity of the body varies with time, and we have to derive equations of motion for uniformly accelerated motion. So when a graph is plotted taking time along x-axis and the corresponding position of the body along y-axis, so we get a parabola like this or like this. When velocity of body goes on increasing at constant rate, we get parabola like this, which is symmetrical to y-axis. When brakes are applied, velocity decreases at constant rate, we get parabola like this. That is, this parabola is symmetrical to time axis. And slope of this graph at any time, if you draw slope, take any two nearby points, draw tangent plane, then the slope of this straight line, this tangent perpendicular over base will give you the velocity of the body at that particular instant. So we can find instantaneous velocity at any time by finding slope of the tangent to the parabola at that particular time. So this is the importance of position time graph. So it means slope of position time graph at any instant will give you the velocity of the body at that instant. Next is velocity time graph. Now suppose velocity of the body is increasing at constant rate with uniform acceleration a. Now when a graph is plotted taking time along x-axis and the corresponding velocity of the body along y-axis, because velocity is changing. So we get a graph, we get a straight line AB as shown in the figure. Now this OA represents initial velocity. Velocity of the body at t is equal to 0. It may be 0 or it may have some value u. And this VC represents the velocity of the body after time t. That is the final velocity. So V is called final velocity, U is called initial velocity, and T is the time interval. So we get straight line AB, draw BC perpendicular x-axis, AD perpendicular BC. So we get triangle ABD and rectangle ADCO. So from this graph, we can derive all the three equations of motion. So how to derive first equation of motion? V is equal to U plus AT. U is the initial velocity, V the final velocity, A the uniform acceleration, and T is the time. There are two methods to derive this equation. You can find slope of this straight line AB. So slope of AB will be equal to BD upon AD. BD upon AD. That is, BD is nothing but V minus U over t, which is nothing but a change in velocity over time taken. This is by definition. Acceleration is defined as rate of change of velocity, or this implies v minus u is equal to at, or this implies v is equal to u plus at. It is required first equation of motion from this graph. Also, you can take by definition, acceleration is given by a is equal to v minus u upon t, change in velocity of time taken. We get the same equation. Then, second, to drive s is equal to ut plus half at square, where s is the distance covered during time t. Again, a uniform acceleration, u is the initial velocity, t is the time taken. Drive this equation, we take area under straight line AB, because we have proved in the previous video that area under PT graph is numerically equal to distance covered by the body. So, area under AB is equal to area of rectangle OADC plus area of triangle ABD. So, divide this area in two parts, area of rectangle plus area of triangle. Now, area of rectangle, area under straight line by definition is equal to distance covered S, and area of rectangle will be OA into AD, OA into AD, plus area of triangle is half base into height, base AD into height BD. So, this implies S is equal to OA is nothing but u, initial velocity, AD is time, plus half, what is AD? AD is v minus u, into what is BD is t. In this equation, we do not require, it is not required v minus u. So, eliminate v minus u from this equation. From equation 1, v minus u is equal to at. Therefore, S is equal to ut plus half at into t, or S is equal to ut plus half a t square, which is required equation of motion, second equation of motion. Very simple. To drive third equation of motion, v square minus u square is equal to 2as. What we have to do? Again, this equation involves distance covered. So, again we take area under straight line AB, but now we take area of the trapezium. So, distance covered S will be equal to area of trapezium. Area of trapezium will be equal to, by definition, half sum of parallel sides BC plus OA into perpendicular distance AD. This is formula to find area of trapezium, which is equal to half sum of parallel sides into perpendicular distance between the two parallel sides. So, we have S is equal to half BC is V final velocity plus OA is U. What is AD? AD is T. Again, from equation 1, we have to limit T here. So, we have S equal to half V plus U. T means from this equation, as T is equal to V minus U upon A from this equation T. So, we have S equal to half A V square minus U square, or V square minus U square is equal to 2as, which is required third equation of motion. So these are the three equations of motion which can be easily derived from velocity time graph. First equation v is equal to u plus at, second s equal to u plus half at square, third v square minus u square is equal to 2as. What we do? We have to simply find slope of the straight line which is perpendicular over base. So we get first equation BD upon AD. So perpendicular BC, BD is B minus U upon E. So we get V is equal to U plus AT. Then to find S equal to 2 plus half AT square, take area under straight line AB in two parts, area of rectangle plus area of triangle, you get the equation. To find third equation, V square minus U square is 2as. So it will be area of trapezium. This is half sum of parallel sides into perpendicular distance. So in this way we can derive all the three equations of motion, which are very, very important to solve some numerical problems. So dear students, ਜੇ ਤੁਹਾਨੂੰ ਮੇਰੀਆਂ ਵੀਡੀਓਜ਼ ਵਧੀਆ ਲੱਗਦੀਆਂ ਮੇਰੇ ਨਾਲ ਜੁੜੋ, ਮੇਰੇ ਚੈਨਲ ਨੂੰ ਲਾਈਕ ਸਬਸਕ੍ਰਾਈਬ ਸ਼ੇਅਰ ਕਰੋ ਵੱਧ ਤੋਂ ਵੱਧ, ਔਰ 9th 10th 11th 12th ਸਾਰੀਆਂ ਕਲਾਸਾਂ ਦੀਆਂ ਫਿਜ਼ਿਕਸ ਦੀਆਂ ਵੀਡੀਓਜ਼ ਤੁਸੀਂ ਫ੍ਰੀ ਆਫ ਕੋਸਟ ਦੇਖ ਸਕਦੇ ਹੋ ਘਰ ਬੈਠ ਕੇ, ਔਰ ਪ੍ਰੋਪਰ ਲੈਕਚਰ ਸਾਰੇ ਟੌਪਿਕਸ ਮੈਂ ਕਵਰ ਕਰ ਰਿਹਾ, ਔਰ ਵੱਧ ਤੋਂ ਵੱਧ ਫਾਇਦਾ ਲਓ। ਆਲ ਦਾ ਬੈਸਟ, ਗੁੱਡ ਲੱਕ, ਥੈਂਕ ਯੂ।